Alright, so I think I'm recording. We're taking a look at skill packet 5, which is exponential functions and log functions. And in skill 5G, we're solving equations, but actually here, the last few problems in 5G day 2 are some application problems. And let's see if we can do these without being too terrified of them. We have it says a 50-gram sample of a radioactive iodine decays in such a way that the mass remaining is given by the equation m of t is equal to 50 times e raised to the negative 0.087 times t, where t is measured in days, and this m of t is the mass remaining in grams. How many days later will the amount of iodine remaining be 25 grams? How long until only 1 gram? So we've got two questions here to answer. All right, so the function, the equation is this. So t is days. So the input for this function is in days. And the output is the mass that initially you started with 50 grams. So when t is equal to 0, then this exponent is 0 and e to the 0 is 1. So our mass is 50 grams. Let's illustrate that. Let's point that out. It's not asking us that. It's just that we're trying to make sense of what this equation is and exactly what the equation provides for us. So initially at time t equals 0, we've got 50 times e to the negative 0.087 times 0. Well, like I say, that whenever you multiply by 0, you get 0. And by definition, as long as your base is not 0, anything else raised to the 0 power is 1. So our mass is 50 grams at t equals 0. Okay, so that makes sense. That's where that 50 is coming from, so I don't have to do anything with that 50. All right. The first equation, how many days? So it's wanting me to solve for t. T is the variable that has days, and the left-hand side, this mass, is the amount. So initially we knew we started with 50, and that it decays, meaning that it's dropping in mass, that it's getting less. It's not increasing, it's decreasing. So this 50 grams, in so many days later, after we start this, we'll be at 25 grams. So the left-hand side is 25. And the right-hand side has the variable of interest that we want to solve for. So now this equation is just like the ones we've been doing. Now the word problem doesn't have really anything to do with it because we've substituted the value and we now know to solve for t. To solve for t. So here's the variable of interest that I've got to get by itself. Well, right now on the right hand side I have two terms, and it's this second term that has my variable of interest. I need to get this factor by itself. I need to divide both sides of this equation by 50. So 25 divided by 50 is 1/2. I'm just going to go ahead and reduce that now. I hope that doesn't bother you. And so now I have to take the natural log of each side and use the product rule in order to get that t down as a multiplier. So I've got the natural log of 1/2 times the natural log of e raised to this negative 0.07t by the product rule. By the product rule. And the natural log of E, we've seen it many times now that we can quickly say that that's equal to 1. So now on the right hand side I have two factors. The factor of interest is t, so I need to divide both sides by negative 0.07. So I've got the natural log of 1/2 divided by negative 0.07. Let's go to a calculator, because that's not really telling somebody natural log of 1/2 divided by negative 0.07 days. That doesn't. Let's give them a decimal, an approximation to this. So we've got natural log of 1/2, close the parenthesis, divided by negative 0.087, 7.967. Well, if it were me and I was telling somebody, I'm going to say, hey, about 8 days, right? I'm not going to, the 7.967 is so close to 8 days, I'm going to say, hey, in 8 days, this 50 gram sample, 8 days later, will decay all the way down to a 25 gram sample. That's what they're asking us. That's what it wants to know. All right, so now for my second equation, here it said the amount was 25. Well, now it's saying what if the amount was 1? So let's go back. I'm going to erase all of this stuff, our previous answer. And instead of 25, it wants me to solve this equation when the left-hand side is 1. Okay. So again, on the right-hand side, I have two factors. It's this factor that I have highlighted that I'm interested in. It has my variable. I'm going to divide both sides by 50. So I've got this e to the negative 0.087t, and I've got 1 divided by 50. So now I need to take the natural log of each side. Now, when you have a exponent on this logarithm, by the product rule, this exponent comes down as multiplication, negative 0.087t, just like it did before, times the natural log of e, which we know to be 1. And to get the t by itself, we divide both sides by that negative value. So now we expect it to be a lot more than 8 days. Like, it only took 8 days for half of it to go away. Well, now, you're dropping all the way down to 1 gram. So it's going to be a lot longer. So 44.96, and again, hey, even though they might have us an exact answer like this, if I'm just telling somebody how long it takes, I'm going to say, hey, it takes 45 days. Because that's so close that if you start with a 50 gram sample of this radioactive material, then in 45 days, most of it decays and it becomes a 1 gram sample. Alright, so I hope that helps, and I'll do these other ones on separate videos, so talk to you later.